Tonight, what we're going to try to do, we're going to take an exploration of the planet's surface of Mars. And we're going to look at that planet through the eyes of rovers. And the first rovers we're going to talk about are Spirit and Opportunity, the two Mars exploration rovers. And then we're going to switch into Curiosity, a larger rover, and its job is to do something a little different. But first, we have to go back in time. And we're going to go back approximately 10 years, a little bit more than 10 years. And we're going to discuss what happened and how Spirit and Opportunity made it to the surface of Mars. So we're going to fly over to Kennedy Space Center in Florida. And we're going to go and we're going to get real close and personal with the Delta II rocket. Now, this is a Delta II rocket. It's built by the Boeing company. It has 3 stages to orbit. And around the bottom side of this vehicle, there's 9 airlit solids. So this is going to help us get a little bit extra lift so that we can get to Mars as rapidly as possible. And if you don't mind counting down with me, 5,
4, 3, 2, engine ignition, and liftoff of the Delta II rocket with the Mars exploration.
At 1 minute and 30 seconds, we're in orbit around Earth. As you see, we're starting to drop away some of those airlit solids. Once those airlit solids fall back away, they get recycled. They get picked up. Once our first stage burns out, we're going to let that go. We're going to light our second stage. Once we light our second stage, we let that first stage fall back to the ocean. It becomes an ecosystem for the fish. We light our second stage. At this point, the spacecraft has very little stability, so we're going to spin it up. We spin it up to about 12 RPM, more or less like a quarterback that throws a nice tight spiral. We're going to get really good flight through the air. We'll light our third stage. This puts us on a direct trajectory to Mars. We're going to do what we like to call the quiescent period, the boring period of traveling through interstellar space. Okay, so now, 7 months later, here we are, traveling at 16,000 miles per hour toward the surface of Mars. We lose our cruise stage because we don't need it anymore. It's pointed us directly at Mars. We're ready to go. We're going to hit our landing site. We're traveling at 16,000 miles per hour, and we hit the upper atmosphere of Mars. When we hit the upper atmosphere of Mars, the friction as we come through literally burns a hole in the upper atmosphere. The heat shield in the front of our rover gets to about the surface temperature of the sun, 1,600 degrees centigrade. At this point, we're going to start what I like to call reverse origami. We're going to pull up a parachute. This is a supersonic parachute, and that's going to start changing our angle of attack from being directly in to being more vertical with the surface of Mars. At this point, we're going to slow down to around 300 to 400 miles per hour. We're going to lose our heat shield because we don't want that heat to come back into our vehicle. And we're going to lower our lander more or less on a shoestring. Once we find the surface, we blow up the airbags. That takes about a blink of an eye, about a half a millisecond, and then we're going to fire some retro rockets. When we get to about 40 meters above the surface, slow down to 0 miles per hour, cut the cord, and bounce. And we bounce, and we bounce. Now, the first bounce of this vehicle could take us over, I use the Empire State Building. We can bounce anywhere from 1.5 miles to 2 miles. Each successive bounce is taking away a little bit of energy, which slows us down. After we lose all of our energy and we come to a stop, we're going to deflate the airbags. So the vehicle senses that we've stopped, and we deflate the airbags. What you saw happen in a few seconds there takes about 45 minutes in real time. The next thing that we're going to do is we're going to open up our lander pedals. We're going to open up these lander pedals. Now, what you're going to see happen in about 30 seconds happens in 45 minutes. The next thing that we're going to do is we're going to open up the solar rays, and if you don't mind, I'll watch too. We got one more thing to do. It's one more part. Okay. Over once it gets over center, oh, okay, all done. Whew. I must have seen this 1,000 times. It doesn't matter how many times I see it. I get very excited when it works because my team and I were the team that designed that, and if it didn't work, we had a very, very bad day on Mars. So when it works, I get a little excited. So open up the solar arrays. Now we can power the vehicle. We're starting to charge up the batteries. The last things that you're going to see happen on this first day is we pull up our PanCam mast, what we call the PMA, and we deploy our high-gain antennas so we can talk directly back to Earth. The last thing that you're going to see the rover do in this animation is it's going to take a panoramic image. One of the things that you want to do when you've landed in a new place is find out where you are. So we're going to take this beautiful image and we're going to start transmitting that back to Earth. So the next day what we're going to do is we're going to stand up the vehicle, deploy the front wheels, and we're going to change more or less our perspective on the surface. When we designed Spirit and Opportunity, we designed the eyes to be at 5'2". That's approximately the level of a human being walking on the surface of Mars. So now, when we take images and we get our panoramic images, it's going to feel like a human being was standing on Mars looking around. We're looking for scientifically exciting sights. Spirit and Opportunity are roving geologists. Their job was to follow the water, to look for water that may have flown on the surface of Mars. And we're going to do that through the history of the rocks. Go up, taste the rocks, touch the rocks, feel the rocks. If you can, break the rocks. Try to figure out, do the rocks tell us something about the history of Mars? So now the last thing that we have to do is drive the rover off the lander. You're going to see the lander change its position a little bit, get ready for the rover to drive off on these things called bat wings. We drive off on those bat wings and we get 6 wheels on the surface of Mars. We call Spirit the bad sister. And not because she was bad in any way, but we drive off the lander, we go up to the first rock. The rock was called Adirondack. We took out our arm, we touched the rock. And as soon as we touched the rock, Spirit did not call home. It's like E.T. went, I no phone home. So we were worried that we didn't understand what was going on with Spirit. Remember that boring period of driving through interstellar space that I told you about? 7 months? So during that 7-month period of time, we had one of the biggest solar flares, solar activities that we've ever seen, right? So lots of gamma rays, bad stuff. I'll call it, the sun burped, bad stuff. Goes flying through interstellar space. So what did we do? First time ever when we were flying a spacecraft, deep space, we actually rebooted the computer. So we turned it off, turned it back on, and then it goes, hey, I'm here, and we're like, oh, goodness gracious, thank you. Okay, it calls back home, we're like, great, great, great. It has all of this great stuff. It starts recording everything that it's doing, all of its maneuvers. It records all of the things that it felt, all the bounces on the surface, everything. 8 days later, it drives off, it touches a rock, and its memory got full. And once its memory got full, the computer wouldn't boot up. And we actually told it to erase its memory. It threw all of that stuff through quiescent space away. And then, oh, hey, here I am, I'm happy, I'll do whatever you want me to do to the rock. And then Spirit became okay. Spirit and Opportunity were, I'll tell you, they were designed to go to the surface of Mars and explore the surface for 90 days and travel up to 600 meters. Spirit was on the surface communicating for more than 5 years. Traveled a little less than 5 miles. Opportunity, the good sister, landed a month later, has been on the surface for over a decade, and continues giving us great information daily. And she's traveled over 25 miles. So, why do we go to Mars? Why is Mars such an interesting place to explore? In the image that you see behind me, on the left is Mars, and on the right is Earth. Looks like where a river or water may have run at some point in time. In this image, I've switched it around. On the left is Earth, on the right is Mars. That image on the right is the largest known volcano in our solar system, the Rocky Planets. It's called Olympus Mons. It's on the surface of Mars. It's approximately the size of the state of Arizona. Go back to the early 70s, 76, 77, and we landed the Viking landers on the surface of Mars. We have Mars Pathfinder, which landed in July 4th of 1997. And then we had Phoenix. And then you have the 2 landing sites for Spirit and Opportunity, this topographical map. Let me show it a different way. For those that like planetary maps, you can see where we landed. And the other thing that you'll see in this is the yellow places are places that we've landed. The ones in white were the possibilities for Curiosity to land. So now we're on the surface. Both Spirit and Opportunity caught some very interesting things on the surface. From orbit, we could see things that look like large tracks, long tracks on the dust and the surface. And we always postulated that they would have to have these dust devils, but we had never seen them. We believe that this is one of the reasons the vehicles have lasted so long. Every so often, one of these dust devils would come by and clean off my solar rays and make us happy, and we make more power, and now the rovers can continue to do their science. Very interesting. Scientifically, this is one of the most important images that we took with the Opportunity vehicle. It was the first time ever remotely with a robotic vehicle that we took an image on the surface at the exact same time we took the image from orbit. So now we can actually do atmospheric science from the ground and from orbit at the exact same time. So, with Opportunity, the good sister, it travels 300 million miles, bounces along on the surface of Mars, and lands in a crater. There's nothing there. It's just nothing, except one rock. And the rock is not from Mars. It's a meteorite from somewhere else. Now, the interesting thing is we've seen quite a few of these now on the surface of Mars. We do know that they're from one of the 4 rocky planets or some of the asteroid belt. We do know that. But where they're actually from, we don't know. Okay? They probably were around sort of the early formation of the planets, but we don't know. But they're very interesting, very exciting. The rover's now here in Endeavour Crater. It's been exploring Endeavour Crater for at least a year now. We've driven down into the crater. We're at a new location inside the crater. We're seeing a lot more of these clays. Right? So now we know that in this location, all across the Meridian Plains, there was a lot of water, deep water. Did you see the change in salinity? Same thing for Spirit. As we drove up Husband Hill, we started to see this change in salinity in the soil. It was a failure that actually told us that. One of the wheels on the Spirit rover stopped working, and so we started dragging it. And by dragging it, we created this trench on the surface of Mars. And as we were creating this trench, when we turned around and took images, we saw the actual albedo, the light that was coming off the soil change. And that started to tell us something's going on, so we started doing more investigation. And we saw this salt level change as we started to get higher in elevation on the mountain. And what it means is as the water was receding, it got much more salty. And that told us that there was water there. Very salty water, and that there was water in both of these locations. So now we know that Mars was a very wet place at one point in time in the past. And we're going to change gears. I'm going to talk about Curiosity a little bit. Curiosity was launched on November 26th, 2011, and landed August 5th. We've traveled for 9.5 kilometers on the surface as of Sol 774. Curiosity was designed to drive 20 kilometers and be on the surface for 1 Martian year. So we've already made 1 Martian year. So we've already made part of our prime commitment to NASA, and that it's been awesome. It's been an awesome couple years. Now, how did we get there? So it's a little different. Very, very similar launch sequence, but it's a different launch vehicle. So instead of a Boeing vehicle, this is a Lockheed Martin vehicle. It's called an Atlas rocket. It's built by Lockheed. It has really just 2 stages to orbit. So you've seen, we've already gotten to orbit. You saw that particular part. Now, this second stage of this vehicle is much more capable. It has some retro rockets on it. It has some thrusters on it. So now it can spin us up, and it can point us directly at Mars. So we did the last kick, and then that's going to fall back and burn up in the atmosphere. What doesn't burn up becomes ecosystem for fish. And now we're going to start going around. So now we're on a direct trajectory to Mars. You're going to see us light up the solar arrays that are around the cruise stage. That's going to actually charge up our batteries. And then what we do is we supercharge the batteries, then we discharge them, and then we keep them about 80% the rest of the way. Now we're traveling a little bit slower because we don't have the same lift capability with the Lockheed vehicle. So we're traveling at 14,500 miles an hour. It takes us a little bit longer because Earth and Mars are at a different orientation. Deploy our parachute again. We're going to lose that heat shield because we don't want to get the heat soak coming back into our vehicle. But now everything's changed. We lose the heat shield, and instead of lowering a lander with airbags, we're actually going to cut some cables, some bolts more or less, and let our rover fall toward the surface. Fire up some rockets, and fly. We added a new science instrument called the MARTI camera. This camera is actually taking images about 32 frames per second. So we're going to zoom in on the camera, and you're going to look at what's going on. So as we're falling toward the surface, the camera is taking images of the surface of Mars, overlaying them, figuring out what is our downrange trajectory and velocity, and is there any obstacles that are in the way. Once we figure out there's no obstacles in the way, we're going to lower our rover on 3 shoestrings and an umbilical cord, really gingerly hit the ground, and once we sense slack in the cables, the cables go slack, we cut the 3 umbilical cords, and the descent stage fires up and flies away. Designed to go 600 meters away from the vehicle. It'd be bad if it came back and crashed on us. That would be really bad. Now we're on our wheels. We're ready to start exploring. So now instead of having to drive off a lander, we're ready to go the very first day. Last things that we have to do is pull up our remote sensing mast, what we call the RSM, and pull out our high gain antenna. The high gain antenna for this vehicle was delivered to us by the Spanish as a gift to NASA. The last thing you're going to see here is as we start driving around with Curiosity is that Curiosity is a different vehicle. Instead of being a roving geologist, it's a roving biologist. Its job is to look for past places on Mars that could have sustained life. We get to shoot a laser at the rocks. Now, why did we do that? Instead of having to go over and touch every rock and taste every rock, and like we said before, we can actually fire the laser at the rock, burn the surface of the rock, and look at the gas that comes off. And from the gas, we can see what the chemical composition of that rock is. What are the elements that are there? The other thing that we did with Curiosity is we added a drill. Now, this is the first time that we'll be able to drill robotically on another planetary surface. Now, we have drilled before with human beings on the surface of the moon. Anyway, what you're seeing here in the video is what we call X-ray fluorescence. We're actually shooting X-rays through the rocks. We agitate them, and we can see how the actual chemicals are held together. What is the crystalline structure? And that actually tells us a lot about what's going on in the rocks on the surface of Mars. Some more of the testing that we've got. And here what you're going to do is we're going to show the mobility system. The mobility system is very similar to the mobility system that we had on Pathfinder and the Mars Exploration Rover, right? It's a rocker bogie suspension system that we've used on all of the vehicles that we've had on the surface. But this one serves a different purpose. It actually is our landing gear. So the wheels that look like they're one monolithic structure of aluminum, they're not. They're about 7 sheets of paper of aluminum on the outside shell. But in the middle is titanium, and the titanium is there to give us sort of a spongy flexure feel. you're going to see us doing some testing. We're driving over obstacles that simulate what we believe we're going to get to on Mars, about 35-centimeter height obstacles. We tilt the vehicle to drive over different surfaces. We drive on the surface. We have 6-wheel drive, 4-wheel steering. So all 6 wheels of the vehicle can drive, and all 4 wheels can turn toe in about 90 degrees, so we can actually turn about our center of mass. So if we wanted to turn in place, we actually could. The vehicle has a top speed of 5 centimeters per second. It's boogieing. It takes us, so I'll tell you what you're doing. It takes us 45 minutes to do a football field. That's how slow we move. So it's really, really slow. Now, when you're 300 million miles away from the nearest gas station, it's okay to go slow. Okay. Where did we go on the surface of Mars for Curiosity? Curiosity went to a place called Gale Crater. So why did we go to this Gale Crater? And the reason we went to Gale Crater is that we wanted to investigate this place called Mount Sharp. And Mount Sharp is this very, very large mountain. It's 5.5 kilometers in size. And what we were looking for is the different layers as you drive up the mountain. So we're going to land, drive to the mountain, and then look at the difference. They say clays. We'll just say it as time periods. So early time period to later time period as you drive up this mountain. Trying to see, can we see places on the surface of Mars that once could have been habitable for life? Could Mars, in this location around the Gale Crater, sustain life, and does it have the building blocks, the basic pieces, to actually have life grow in that location? Then we got some of the first images back. So this was actually after the first drive, and you see the name Curiosity. After we got to the surface, we started taking selfies. So this is one of the first selfies of the rover. It's a shadow. We weren't really good at it yet. Then somebody had some fun with one of our images. Optimus Prime came and visited us. So that's fun. We have a laser. It's so great. We have a laser. Here's what people think we do. Sort of fun. Here's what we really do. So you have the picture on the left, undisturbed soil, picture on the right, 5 laser holes. I'll show it to you a different way. We'll show a video. So here's a video of us burning a hole in the ground. Pretty exciting. You can see sort of the byproducts coming off. You can't see the gas. But what we're actually doing is we're burning a hole looking for the gas so that we can tell what it's made of. So the first thing that happened after we landed, we drove to this area on Mars that was very interesting. Within the first 3 months of being at this location, we were able to say, 1, Gale Crater was wet. Number 2, it can sustain life. Now, we can't say that there was life there, but we can say that if there was, it would have been able to be sustained. There are all the chemical compositions that are needed to support life. Paying homage to some of our great explorers before us, the footprint of Buzz Aldrin, and then Curiosity rover footprint. Our first scoop, so we now went down and we scooped up some of the dirt. We're going to actually take that inside the vehicle. Some more of these analogs. So looks like riverbeds. Picture on the left is uncorrected, just an image that comes back from the surface of Mars. Looks like a riverbed. You can see false cover image of Mars that's sort of in the middle, and then an Earth riverbed. Looks very, very similar. Here's the first time we're going to sample. We're going to drill on the surface of Mars. I can tell you this took a long time. It took us about 4 weeks to actually make this one little hole. There's a picture of the hole up close. The next image is after we've taken that and we ingest it inside, we can actually separate different particle size. So we can take things that are down to a couple microns, we'll sieve those out, and then we can deliver those to different instruments. Here's a picture of Mount Sharp. This is where we wanted to go. It was an early picture. There's a rock that's out in the distance. That rock is 5.5 kilometers away from our rover, and it's approximately the same size as a rover. And we're thinking, oh my goodness, it'd be so great if we could make it there. The other thing that you'll notice in this image, if you're looking closely, is there's clouds. Mars does have clouds, just like Earth, right? So there is moisture in the atmosphere. So this image shows sort of our trajectory to get down to the start of the mountain. And as we were driving, we were starting to figure out, oh my goodness, there's parts of Mars that are really, really scary. And the reason they're really, really scary is that the rocks that are on the surface are different than we've ever seen anywhere else on the surface of Mars. As we were driving on Mars with Spirit and Opportunity, we'd hit a rock and we'd break it, or we'd push it over and move it out of the way. In this particular area, the rocks are like cemented into the ground. And then they have this word, I don't know, I'm just going to use it, it's called venefacted rocks. Other words, the rocks are windblown. So if you can imagine, you're covered with water, and as the water recedes, the wind starts working on the rock, and as it recedes, it sharpens the rock. So the rocks look like teeth, very, very sharp teeth. And as we're driving over them, we're puncturing holes in the wheels. So we thought, oh my goodness, one, we have to figure out how not to hurt our wheels, and number two, we have to figure out where to drive around things. So you can see, we take sort of this really crazy path. And then we got to the place that's at the end of this particular image. And the scientists had a choice. We could go right, effectively right from the rover's perspective, and go through this area right here, which is a choke point. There's really no way to get out if you get in there. Or we could go straight. Very, very bad rocks. So we chose to go right. So we go right. We end up right. We take some images of our wheels. We started to see lots of wear as we were driving over this area called the Hummocky Plains. And the hole that you see is sort of benign. The thing that's actually really scary is the hole that's underneath that. And the reason it's scary is as we're driving over the surface, what we're going to do is the wheel is taking load, right? It's moving. It's actually getting stressed. And every time you do that, you're actually having this crack propagate. And we were worried, oh my goodness, how are the wheels going to fail? These cracks are going to propagate across the wheel, and then part of the wheel is going to fall off. And the part of the wheel that falls off isn't going to hit anything that's bad, because there's cables all around this. So as the wheel falls apart, is it going to do this? So now what we're doing is selectively on different soils, we're driving the rover backwards. So driving backwards actually takes a little bit of the load off the front wheels, about the same on the middle wheels, and then starts to do some damage to the back wheels. But that's okay because they're not damaged at all at this point. So we're going to start to try to even out the wear across the wheels so that we get a little bit longer driving. The other thing that we noticed, and I told you we went to that choke point, is that with damaged wheels, we could drive over sand dunes better. So climbing over nice light stuff was actually better with these holes in the wheel. So we turn right, we get to the sand dune. Now we've done some testing, we know that we could drive over it. But as all good engineers and all good scientists go, we go, well, what happens if there's really sharp rocks underneath the dune? So we argued for about 2 days about driving over this dune, and I'm thinking, golly, it's only a meter tall. So it's a meter tall, 3 feet. And the rover's belly is 75 centimeters, so 3/4 of a meter. So if it was really just light, fluffy, sand dune, we would get stuck. But the reality is the rover would sort of float over it. But we were freaked out for a little while. So we did some testing, and then we decided to go. But we didn't decide to go all at once. We put a toe in, and then put another toe in. And we drove up to the top and looked over, and we drove back. And then we said, OK, go. So here's the image from the other side. Here's a video of us driving over that particular obstacle. Sort of fun. But it took us a while to do that. Then we have where we've gone. So we land at Bradbury. We go over to Yellowknife Bay. And now we're at the Prump Hills. And the Prump Hills are more or less the gateway to Mount Sharp. Our first drill at Prump Hills. Now you can see it really looks sort of clayish. We do some close-up investigation. We can see these lines, looks like secretions and hard stuff around it. The mineral that we believe that's there, and we're just doing some investigation right now, looks like hematite, which only forms in water here on Earth. So it looks like we're finding another place that was really wet on the surface of Mars. And then we can talk about what's coming next. In 2020, we have a new rover, and you can see some of the science instruments. The Science Suite has been announced. You can see the international collaboration that's going to happen. Very, very similar vehicle to Curiosity in terms of size, but has a different mission. And its mission really is going to go sample the surface of Mars and capture those samples and hopefully return them back to Earth. So now as I close, I'm going to show you some of my favorite images from the surface. This image is from Curiosity. And you see that star that's out there? It's Earth. And in high resolution, you can see the moon. And now I'll show you my favorite video, my favorite image. This is from the top of Husband Hill. This is one of the last things that we got from Spirit. And if we had been able and had a little bit better camera, we could have seen Earth set. But I'll show you this as a video. And this is the sun setting on Mars. And the thing that makes me love this image so much is literally the fact that someday a human being will stand on the surface of Mars and say, I'm watching the Earth set, and then I'm watching the sun set, and I can't wait for that day. Thank you guys so very much. It's been awesome.